Hello everyone. So in this video, we are going to see why our rotor slots is skewed in three-phase squirrel cage induction motor. So you can see the rotor bars are not exactly parallel to the rotor shaft, but it makes some kind of angle. Some kind of rotor bars makes an angle. So here I have described it is in theta. So why it is so? It is basically it is done to remove the certain uh, harmonic torque. Okay, you might have studied a phenomena called crawling. In crawling, because of space harmonic, the rotor start to rotate around 1 by 7th of the synchronous speed. So that cause the motor start rotating at the very low speed. That low speed produce lots of heat loss in the machine. That is reduce the machine life and it produce a lot of losses. So it is a not of good phenomena. So to reduce all of the harmonic torques and the effects, we basically prefer to do this skewing. So what we need to do, we need to analyze the cause basically. So if I just describe the flux distribution in the induction machine, it is not a uniform. Not a uniform means like I'm trying to say it is not sinusoidal. It is a non-sinusoidal in nature. The flux distribution, if you travel in the air gap, the flux distribution is non-sinusoidal. For example, maybe the waveform will be something like flat top in nature, something like that, or something like that. So it has it has the fundamental component and it has the triple harmonic component and all, right? So if I draw the fundamental waveform, maybe it will something like that. Okay, and if I draw it is a fundamental waveform v1, and here by this here, for example, if I consider seventh harmonic component, seventh harmonic component will complete seven cycles. 1, 2, 3, 4, 5. Let me remove it. 6 and then 7. So you can just say here, by the time fundamental component is completing one cycle, the seventh harmonic component is completing 7 cycle. Okay, first cycle, second cycle, third cycle, fourth cycle, fifth cycle, sixth cycle, seventh cycle. Okay, now if this particular area is positive, I can say it is producing north pole, and this area is negative, so it is producing south pole. So similarly, the harmonic component here, it will produce north pole, south pole, north pole, south pole, something like that. North pole, south pole, north pole, south pole, north, south, north, south, north, south. So how many it is creating? 1, 2, 3, 4, 5, 6, 7. So seven pair of poles, like seven pair of poles. So 7 times of the fundamental pole. So if the fundamental is producing 2 poles, it is producing 7 into 2, 14 poles it is producing, right? So something like, because of this harmonic in the flux or mmf, whatever you say, it will also produce this non-sinusoidal waveform will produce induced emf or current in the rotor circuit. Okay, so if you see a basic thing, let's say you have a machine with you and it has a conductor a dash, and you have this rotor, you have a rotating magnetic field, that is n pole, and this south pole that is rotating somewhere in this direction, and it is a dash coil. So if I see, this a is influenced by north conductor and a dash is influenced by the south pole. Okay, so they will induce a opposite polarity voltage. For example, it is inducing in this polarity of voltage e. So in this case, the another one a dash coil will produce with this polarity e voltage. So take if you KVL, so you can see Vx plus minus E equals to Vy. So Vx minus Vy is equals to 2E. Okay, so some voltage getting induced. So if you want to produce some voltage, if one conductor is under north pole, another should be under south pole only, then only you will get some voltage. Okay, so now to nullify the seventh harmonic torque that getting produced because of the seventh space harmonic, if I do this kind of arrangement, like something like that, one side is under north pole, another side of the conductor is south pole, then if this side is producing voltage of this polarity, this side will also produce a voltage in this polarity, such that if you take KVL, it will produce 0 volt here. If the rotor is producing 0 volt, then the rotor current is also zero. The rotor current is also zero. If the rotor current is zero, the rotor flux is also zero. If the rotor flux is also zero, the torque production because of the seventh harmonic component F phi s, phi r, sine delta, this component is zero. Obviously, these are the seventh harmonic component in the stator. Seventh harmonic component is in rotor, which is zero here. So simply the torque production because of my this arrangement, because of my skewing, that torque production because of the seventh harmonic will be simply zero. So your torque production will be uniform, or torque production will be very good. So like electromagnetic torque will not cause any kind of crawling phenomena. So by doing this skewing, you are trying to you're trying to be part of, you're making the one part of the conductor under north pole, another part of the conductor is south pole. Now that is in your hand, by choosing theta, how much theta you want to choose, such that you can nullify a particular harmonic torque. Okay, I hope it is clear.